So group 7, and this is the second part. This is part 2 of group 7. There's a group 1, part 1 video as well. Okay, in this group 7 part 2, we're just going to focus on 3 elements, 3 halogens in group 7. Okay, so exam papers, A-level exam papers, focus on chlorine, bromine and iodine. And that's what we're going to focus on, these elements in this video. Okay, first you need to know what the physical state is of these elements at room temperature. So chlorine is a gas, bromine is a liquid, and iodine is a solid at room temperature. You need to know the colour of these elements at room temperature, and chlorine is a very pale green gas. Bromine is an orange liquid. Sometimes looks a little bit brown depending upon the concentration of it, but it's an orange liquid. And then iodine is a solid. Now the appearance of iodine is looks like a dark, the actual solid looks like a dark grey, has a slight kind of metallic look about it. It's a dark grey solid. Okay, so chlorine's a pale green gas. Now iodine has kind of a special quality. Okay, if you take in a test tube, if you take some and you put some cotton wool to stopper the test tube, if you put some iodine solid in the bottom of the test tube, okay, it's like a dark grey, slightly metallic looking solid, and you heat it up, maybe put it in a beaker of water, put in a beaker of hot water, something happens to the solid, and what you'll find is you'll get purple. You'll see a purple gas appear, forms a purple gas. And iodine has a special quality in that it sublimes, and that means it goes from the solid to the gaseous phase without passing through the liquid phase. So if you take some iodine solid and you warm it up in some hot water, then it sublimes and it forms a purple gas, which then turns back into the solid on the side of the test tube, so sublimes. Okay, now you need to know the colours of these 3 elements in aqueous solution, so in water. You need to know the colours in water in aqueous solution. Okay, so the colour of chlorine in aqueous solution is again just a very pale green solution. The colour of bromine in aqueous solution is an orange solution. So very straightforward. And iodine, when you dissolve iodine in water, it forms a brown solution. So you do need to know the colours of these in aqueous solution. Now the problem is with the orange and the brown, they're very similar depending upon the concentration. Some people may see it as orange, some people may see it as brown, so it's not very clear. So what you do is you add an organic solvent. You add an organic solvent to make the colours clearer, so you can tell which element you have got. Okay, so if you've got a test tube, and you put in there some, for example, some bromine dissolved in water, some bromine in water. Okay, actually, I don't know why I've drawn it sideways. I'm going to draw it again, but draw it straight up like this. Okay, and you've got some bromine in water, and you're not quite sure whether it's bromine or not. It's orange, so you're thinking it's bromine. And then you add an organic solvent. So something like, a common one we use is cyclohexane. So you know the formula of cyclohexane? Cyclohexane is 6 carbons in a hexagon, like that. Cyclohexane, common solvent we use. So it's bromine, it's orange, but you're not 100% sure. So you pour in some cyclohexane, and the organic layer sits on the top. This is the organic solvent. Organic solvent sits on the top, and you stopper it and then you give it a mix, and then what happens is you get a different colour. You get a colour comes out in the organic solvent. Okay, the halogens, the elements, are more soluble in organic solvents. Why? So they're soluble in water, but they're more soluble in organic solvents. So you give it a shake, and the colour at the top becomes more intense, more darker. So why is that? It's because the halogens, chlorine, bromine, iodine, are simple molecular structure, have weak van der Waals forces, between the molecules, and so does organic solvent. This is exactly the same for organic solvent. Organic solvents like cyclohexane, they're not polar. So this is non-polar. Chlorine, bromine, iodine are not polar. Organic solvents are not polar either, are non-polar as well. They don't have any oxygens, nitrogens. They don't have any dipoles. And so, like, the phrase we use is like mixes with like. Like mixes with like. Like mixes with like. So non-polar mixes with non-polar, and polar mixes with polar. And water is a polar solvent, and whereas bromine is not polar. So it's a lot more soluble. Halogens are more soluble in organic solvents. So if you want to check which halogen you have got, you put in some organic solvent and give it a good shake up, and the colour is more intense in the top layer. Okay, so for chlorine you get the same colour, still a pale green, but it's like a more intense colour. You can see it a lot easier. And again, this is still orange in the organic solvent, but it's a more intense, a darker colour. Okay, and we're just going to put more intense colour, darker colour of orange. And then when you add to aqueous iodine solution, you add some organic solvent, and it's the top layer, and you shake it up. Then the top layer becomes a purple colour, and then it's really clear. I've got iodine solution, not bromine solution. So if you're a bit confused with the colours from the aqueous solution, you add an organic solvent, and then the colour becomes very clear. I've got it's darker orange, so that must be bromine. If the organic layer turns purple, then that must be iodine. Okay, right, so what else we need to do? So if we take, those are the colours of the elements in water and in organic solvent, right? So if we have, let's take this reaction for example. Let's take a reaction, let's take chlorine, okay, and I'm going to do an Ionic equation, okay? So I'm reacting chlorine with like sodium bromide, for example. Let's do the proper equation first. So it's all aqueous. Chlorine and sodium bromide. Okay, that makes sodium chloride, aqueous, and bromine. Okay, that's the chemical equation, all aqueous. So I'm going to just write the Ionic equation now. The Ionic equation. Okay, and that is chlorine plus 2Br minus 2Cl minus AQ plus Br2 AQ. Right, the sodium ions, the two sodium ions are spectator ions. They're not involved in the reaction, and they just cancel out. Okay, so now we've got the Ionic equation. All right, now let's have a look at oxidation states. What's the oxidation state of chlorine? This is chlorine and water. What's the oxidation state of chlorine? It's an element, so its oxidation state is 0. Okay, what's the oxidation state of the Cl now? It's just the charge, so it's -1. Okay, so Cl has gone from 0 to -1. The oxidation state has reduced, it's gone down, it's decreased. The oxidation state has reduced, so we call that reduction. Okay, and remember the relationship, remember the oil rig, where oxidation is the loss of electrons and reduction is the gain of electrons. Okay, so can you see here that chlorine has actually gained electrons because it's got no charge, and then it's minus, it's gained electrons. Okay, let's have a look at the bromine. The bromine is -1 and the bromine becomes 0. Okay, so here from -1 to 0, the oxidation number has increased, and that is oxidation. But can you see that the Br has an electron, and then it has no charge, it has lost the electron. So Br minus has been oxidized. So I'm just going to write that down. Okay, just going to write a little message about that. So the Br minus has been oxidized. The bromide has been oxidized. Okay, and the chlorine's been reduced. Has been reduced. Okay, chlorine has been reduced. So, is the chlorine acting as an oxidizing agent or a reducing agent in this reaction? So, the bromide has been oxidized, right? It has lost an electron. And the chlorine has gained the electron. The chlorine has helped. The chlorine has helped the bromide lose an electron, be oxidized. Okay, it itself has been reduced, but it's helped the Br lose an electron. So chlorine is acting as an oxidizing agent. Okay, a good way to think about it is like an estate agent. An estate agent helps you, an agent to help you buy a house or sell a house. The estate agent doesn't buy your house. It helps you to sell your house. So it's an agent. So chlorine is an oxidizing agent because it is helping Br be oxidized. Okay, so chlorine is acting as an oxidizing agent. It helps something. It helps Br minus be oxidized. It helps oxidizing agent, but it itself is reduced. Okay, so and that is what is happening. Okay, but why is that happening? Why is chlorine removing the electron from bromide? Why is that happening? And that is because chlorine is more reactive. Chlorine is more reactive. Chlorine is more reactive than bromine. Chlorine is more reactive than bromine. Okay, bromine's got the electron, but chlorine wants that electron. Chlorine has a greater affinity for that electron. It attracts that electron stronger because it's smaller, has less shielding, has less shells. It's got a greater ability to attract that electron. So chlorine is more reactive than bromine, so it removes the electron. Okay, these are called displacement reactions. Displacement reactions. Okay, they are also, it's got another name, everything's got more than one name. It's a displacement reaction, but it's also a redox reaction because something is reduced and something is oxidized. It's a displacement reaction, but it's also a redox reaction as well because something is oxidized and something is reduced. So a displacement reaction is when a more reactive halogen will displace a halide of a less reactive halogen. Oh, reactive of a less reactive halogen. Okay, let's have another look at another example then. So if we take, I'm just going to write the Ionic equation. If we take, let's take bromine. Take some bromine water and add it to sodium iodide in solution. Okay, bromine is more reactive. It's more reactive than iodine. It will take the electron because it's more reactive. It wants that electron there. It will take the electron and become reduced, and then iodine will go back to being the element, the halogen, like this. Okay, and then how can you tell? So bromine has been reduced, iodine has been oxidized, bromine is acting as an oxidizing agent. It's helping iodide lose electrons, helping it be oxidized. How can you tell this reaction's happened? Well, you can tell this reaction happened because this is orange in water. That's an orange solution in water. But now you should have a brown solution now in water. But it might be difficult to tell because orange and brown solution are kind of quite similar colours. So what you do is you add some organic solvents like cyclohexane, and the top layer, mix it up, and the top layer will go the colour, what? Will go purple colour. Or actually, I've said purple colour, but quite often we also say violet. Purple violet colour. Okay, purple violet colour. Okay, violet colour. And then you know that this reaction has happened. Okay, what about this reaction here? Let's try this one. So let's try iodine in solution plus chloride, chloride like sodium chloride, and you put those two together. What's going to happen when you put those two together? Nothing's going to happen. It's going to be no reaction because iodine is not reactive enough. To remove the electron from the chloride. Chloride is smaller radius, it's got fewer shells, less shielding, it's got a strong attraction for this, nuclear attraction for this electron, and iodine is not reactive enough to remove the electron. The only thing that will remove the electron, which element will remove the electron? Fluorine. If we had fluorine, that would remove the electron because fluorine is the most reactive. Okay, so in group 7, which element is the strongest oxidizing agent, i.e. it's the most reactive? What we're saying is the most reactive. Basically, we're saying which one is the most reactive, and that is fluorine. Okay, right, last thing quickly before we finish, you need to also know about disproportionation reactions. That is an enormous word, disproportionation reaction. So let's spell it carefully. Disproportionation reactions. Okay, this means when the same element in a chemical reaction is both oxidized and reduced in a chemical reaction. The same element is both oxidized and reduced in a chemical reaction. Okay, so a classic example of this with group 7 is when you take chlorine water and you add it to water, and this is to kill the germs. This is used to kill the germs, the bacteria in the water, like in swimming pools, for example. Okay, and then you get this compound made, plus we need to balance it. What else is going to be made there to balance it? got HCl Aqueous, okay, and that's what's used with chlorine is added to water to kill the germs. And if you see here, the oxidation state of chlorine is 0. Okay, the oxidation state of chlorine here is -1 because hydrogen is +1. The oxidation state, so oxygen is -2, hydrogen is +1, so therefore chlorine must be +1. So chlorine has been both oxidized and also it has been reduced, all within the same equation. And that is called a disproportionation reaction. Another example of this is when household bleach is made. Just bleach, used for cleaning things, is formed when household bleach is formed. And this is when cold dilute sodium hydroxide and chlorine are reacted together. Cold dilute. So if you take chlorine and sodium hydroxide, AQ, okay, and then that's going to make, it's very similar to the top one, really similar. It makes NaClO plus, that's aqueous, plus sodium chloride, plus something else. We need 2 of them because we've got 2 sodiums, plus we just need to balance it. The other item is going to be water. Okay, and then that's 0. Oxidation state here -2, oxygen's -2, sodium is +1, so chlorine is +1. So that is an example. The oxidation number has increased. That's oxidation. Chlorine, sodium is +1, chlorine is -1, so chlorine is -1. That is an example of reduction because the oxidation number has reduced. And that's another example of disproportionation. Okay, let's just put the names. This chemical here is called chloric 1 acid, and the 1 means that chlorine is in the oxidation state +1. Chlorine 1 acid. Okay, and this one here is called, this chemical here is called sodium chlorate 1, and again because the chlorine is in oxidation state +1.